this first bit of questions that I'm going over, I just took this from the 5.1 WebAssign. So you guys don't have these in front of you. Go ahead and download the 5.2 notes because that's what we're going to go through today. But 5.1 and 5.2 go hand in hand. All right, 5.1 is talking about simplifying. If you guys go into modules, there is a file that says, at the bottom of the modules, it says Trig Identities. This is that. You will get this on your test and quiz. You guys do not have to memorize these. Yeah, you do not have to memorize these, so it's good. But you should put this next to every single problem that we do. You have to be able to apply these. It doesn't make any sense, doesn't do any good if you have them, but you have no idea what they mean. So what I want you to do on a little sheet of paper, whatever, somewhere on your notes, I want you to write these things down, some important things. When we're talking about trig functions, we're talking about verifying and simplifying, you need to 100%, and I'm going to say this a million times, think algebraically. That's how our brains work. You guys are very, very good with thinking algebraically. You'll see what I mean by that in a minute. But you want to always think algebraically. The second thing I want you to remember, to write down, I'm going to refer to a lot. There's two trig functions that are our most basic. And when all else fails, try to convert to these two. What are they? Sine and cosine. Your two most basic trig functions. And you guys already know this. Some of you sent me messages. I don't remember how to do the 4.4 stuff. Guys, you cannot just let that slip out of your brain. That's why I left that as a review. I thought I was just going to be gone on Monday. Think about this. Let's go back to 4.4. You have an angle that is on the unit circle. You guys are familiar with the unit circle. You have an x value and you have a y value, correct? What trig function is represented by the x value? Cosine. Good. What trig function is represented by the y value? Sine. Perfect. All right, we know that. Awesome. So if I asked you guys to find the tangent of this angle, whatever angle we're talking about, how do you find tangent? What over what? It's y over x. What's cotangent? X over y. If I asked you guys to tell me the cosecant, it's 1 over what? 1 over y. If I asked you to tell me the secant, it's what? 1 over x. Okay, that's all from 4.4, correct? You guys with me? So here's our trig identities. We have reciprocal identities. We have quotient identities. Guys, you already know this. Sine, its reciprocal is cosecant. So remember, sine is y, right? If I asked you guys what the cosecant was, you would tell me it's 1 over y, correct? What about tangent? You told me that tangent was y over x, correct? Well, what is the y value when we have something on the ordered pair in the unit circle? The y value is what? Sine. The cosine is x. Y over x, sine over cosine. You guys already know these reciprocal identities. All we're doing is now, instead of using x and y, we're using the trig function, the name. These ones down here are new to us. These are called Pythagorean identities. Again, you're going to be given these on a sheet of paper. What makes these Pythagorean identities? Well, what do you guys notice? They all have what? They all have squared. What's our Pythagorean theorem? A squared plus b squared equals c squared. Okay. What else do you notice these all have? See how they're attached with a plus 1? So you're going to use these identities and you're going to be able to apply them. I promise you. We're going to have to think algebraically though. What I mean by that. Do you see this first trig identity? Our Pythagorean sine squared plus cosine squared equals 1. All right? If I were to think algebraically, instead of it saying equals 1, I want it to say cosine squared. What can I do? How can I manipulate the blue formula so it says cosine squared equals? Tell me.
Minus sign.
If I minus the sign from both sides, am I allowed to do that? Yeah, think algebraically. So cosine squared is the same as 1 minus sine squared theta. Perfect. You have to be able to manipulate. You got to be able to move these around. What if I wanted it to say sine squared? Do you guys agree that sine squared is the same as 1 minus cosine squared? Okay. You're going to have to be able to do that with all three of these. How could I say tangent squared equals? So tangent squared equals what? Secant squared minus 1, right? Do you guys understand that algebraic, you're moving stuff around. If you move something from one side of the equal sign to the other, if it's positive, you subtract it. If it's subtracted, you add it. Same concept. Does everybody understand that? So when you come to a problem like here, right, I have 3, that's a beta. If you want to change every single thing to a theta or a smiley face, I don't care. But this says 3 cosine theta times tangent theta, okay? The first thing you should do is get your identities and stick them next to every single problem you do. We're going to simplify. What does it mean to simplify? Make smaller. Deal. All right, we're going to make smaller. So the first thing that you say is, okay, do you have an identity that's squared that has anything added to it, like a plus 1? No. So we don't look at our Pythagorean identities. We don't have any plus or minus signs. This makes our problem real easy. This is all just multiplication. So if we're going to simplify or make smaller, I'm going to go ahead, excuse me, and I am going to simplify by changing everything to the 2 most basic trig functions we have, which are sine and cosine. Good. So if I change this to sine and cosine, this is going to become 3 cosine theta. Agreed, because it's already simplified. What do I change tangent to? Sine over cosine. Perfect. You guys agree that this is over 1? Right? Now, this is just 2 fractions that we're multiplying, right? Think algebraically. If you have something in the numerator that's exactly the same as something in the denominator, what do? You cancel. So this cosine cancels with this one, and I'm left with what? 3 sine theta. That's it. That's it. We're always going to think algebraically. If you have 2 fractions and you're adding them together and they don't have the same denominator, what do you get? How do you add them? You get a common denominator. Good. All right, let's look at the next one. And again, we're going to go through a bunch of these, I promise. It's over the next few days. So I have cosine theta, and then 1 plus tangent squared. All right, we're trying to simplify, trying to make smaller. First thing, I always go through the same thing and I say, do I have a trig function that is squared that has a plus or minus 1 attached to it? Do I? Yes. So where should my eyes go? To the Pythagorean identities. Which Pythagorean identity would I use? What is 1 plus tangent squared the same as? Secant squared. So, okay, good. Keep your cosine. Good job, guys. So this is going to become secant squared theta. Now, we've already simplified because we went from 2 terms, right? A 1 and a tangent squared with the plus in the middle. We simplify that to 1 term. So now I say, okay, what are my 2 most basic trig functions again? Sine and cosine. So I'm going to leave cosine over 1 here. What am I changing secant squared to? 1 over cosine squared. Good. Some of you are like, how come it's squared? If that said secant to the 5th and you change it to cosine, it would be 1 over cosine to the 5th. Whatever the whatever the exponent is stays with it. All right, so we're multiplying fractions together. What happens here? Okay, 1 cosine cancels here, 1 cancels here, so I'm left with 1 over cosine. That's pretty darn simplified, but I can smush it together a little more. Look at your reciprocal identities. 1 over cosine is the same as what? Perfect. Is this incredibly difficult? No. Is it a lot easier when I do it with you? Yes. I know that. Some of you are like, oh my gosh, it's so easy. And then when you sit down and do one by yourself, you're like, wait, what? It's always that first step that's the hardest, and it starts to roll together. Sure. All right, look at the next one. All right, we're going to think. I have tangent squared, whatever, minus tan squared sine squared. Okay, so let's talk through our thing. Do I have a trig function that's squared that has a plus or minus 1 attached to it? No, not yet. I could go to sine and cosine, but I'm going to look and I'm going to say, what do I see? Do you guys notice anything? Do you guys agree that there's 2 terms here? Here's 1 term, and here's another term, right? If I said to you guys, do you notice anything in common here? In the green. What do they have in common? No, in the green. X squared. And I would tell you to do what? How would you factor it out? What would you say? Take out the x squared, Miss Meadows. We've done this a million times. Then you're left with 1 minus y squared, right? Exact same thing, guys. We are thinking how? Algebraically. Yeah, this is trig function stuff. It looks funny, but you can still, the math is still the same. What do they have in common? Tangent squared. When we factor something out, do we just take it out and throw it away and don't play with it anymore? No, we bring it out in front. So I take out that tangent squared. Now I'm dividing both of these by tangent squared. What happens when you divide tangent squared by tangent squared? 1, good, minus what? Sine squared. Perfect. Now, why did that help us? How did that help us simplify to combine? Because what did we just create, guys? When we took that tangent out of both, what's 1 minus sine squared the same as? Look at you. 1 minus sine squared is the same as cosine squared. Some of you are like, how'd you know that? Think about it. If you have a trig function squared and it's attached to a plus or minus 1, we look at those identities. When you look at that identity, you go, oh, it's that first one. Can I manipulate it? Can I move it around? Now that we have both of these, there's no plus or minuses anymore. I don't have to worry about anything attached to a 1. What are my most basic trig functions? So I'm going to change tangent to sine squared over cosine squared, yeah? And then this is cosine squared over 1. Everybody with me? All right, I'm thinking algebraically, guys. I'm multiplying two fractions. If the numerator and the denominator are the same, what can we do? We can cancel them out. So what am I left with? Sine squared. Now I'll show you in a minute why I think verifying is a little easier. Yes, tell me.
How did you get the cosine squared?
Because this right here, see how I have 1 minus sine squared?
Yeah.
So I think to myself, okay, sorry. I have a trig function squared, and it's attached with a plus or minus to a 1, right? So I went over to my identities, and I said, which trig function identity has sine squared and a 1 with it? It's this one. And then how, if I move this sign over, it becomes 1 minus, right?
Yeah.
And then that's cosine. All right, let's look at this next one. All right, I'm going to rewrite it because I don't like the betas. So sine theta, tangent theta, my stomach's growling, plus cosine theta. All right, this one's a little different. We're going to have to think a little bit. Let's think a little bit. All right, first question. Is there a trig function squared that has a plus or minus 1 attached to it? No. Okay. Darn. That plus sign's a problem, though. Can I just change everything to sine and cosine and then start canceling? Are you allowed to do that with a plus sign? No. All right, our rules apply. Let's go ahead and go to sines and cosines. So I'm going to rewrite this. I have sine theta. Just going to put it over 1. What am I going to change tangent to? Sine over cosine. Okay, perfect. And then I have plus cosine over 1, right? Now, why can't I just go ahead and randomly cross out the cosines? Because there's a plus sign, remember? Algebra, you're not allowed to do that. So let's just simplify a little bit. What's sine times sine? All right, so sine squared theta over cosine plus cosine over 1. What am I looking at? Algebraically here, what am I looking at? Two what?
Fraction.
Two fractions, and we're doing what? Adding them. If I have 1/2 plus 1/3, what would I have to get first? Common denominator. Okay, fine. What's a common denominator between cosine and 1? Okay, so my common denominator is going to be cosine. So I look at my first fraction. It has the cosine, so sine squared is going to stay, yeah? Deal? My second fraction, if I multiply the bottom by cosine, then I have to do what? The top by cosine. Perfect. What's cosine times cosine? Cosine squared. All right. So now I have trig function squared with a plus sign. Look at your identities. Which identity is going to help me here? The first one. What is sine squared plus cosine squared equal to? 1. This whole thing, ladies and gents, is equal to the number what? So this is 1 over cosine. That's pretty simplified, but can we smush it together a little bit more? Yep, 1 over cosine is secant. Good.
If we just put 1 over cosine, we get points taken out.
Yeah. All right, I did all those to then come to this one, and I hope you guys look at this and go, oh my gosh, this one's so easy. Why is this one easy? What does it not have? Nothing. No plus signs, good. There's nothing squared. I don't have fractions that I'm adding together. Guys, what do we do now? If we just start off with 2 trig functions that aren't sine and cosine, what should we do? Make them sine and cosine. So I'm going to rewrite this as 2. What is secant? 1 over cosine. So do you guys agree with me? If I have 2 times 1 over cosine, can I just write it as 2 over cosine, like that? Okay. And then what is cosecant? 1 over sine. So algebraically, what am I looking at? 2 fractions that we're doing what? Dividing. So when we divide fractions, we keep, change, flip. So 2 over cosine theta times what? Sine over 1. Okay. Is there anything to cancel out? No. So if I just multiply them together, I have 2 times sine theta over cosine theta. Look at your chart. Sine over cosine mean anything to you? Yep. Now, simplifying. Why is simplifying hard? Because some of you guys don't know when to stop. You're like, how do I know? How do I know I'm done? That's why simplifying, it can be difficult. But we use simplifying. We use the whole thing to then take us into verifying. So that's what we're going to do now. All right. If you look at your web assignment for 5.1, I'm glad that Savannah just asked that question. Silly things like if you put in a theta and it should have been a beta or something, it'll mark it wrong. Don't let that frustrate you. For 5.2, I'm going to show you, all I want you guys to do is use the web assign for the problems itself. You do not have to submit your score with WebAssign for 5.2. You'll see why in a second. It's a pain. But go ahead and go to your notes here, guys, for 5.2. We're going to do the first 3 examples. What I'd like you to do for homework tonight is to try the second 3. If you want to do your other homework, that's fine as well. Come in and ask questions, fine. But we're going to finish up the notes tomorrow. But when we verify, what does it mean to verify? To check, all right? We're going to prove. You guys are going to be given a statement, a trigonometric statement that says something equals something. The left-hand side is the same as the right-hand side. That's what it's going to say. And you guys are going to go through and you are going to prove that this is the case. All right, here are the steps. The first thing I want you to look at, it says to work with one side of the equation at a time. It is best to start with the most complicated side first and simplify it. You'll see what I mean in a second. Secondly, it says look for opportunities. You want to try and factor, add fractions, square stuff, use your identities. That's what you're trying to do. You're trying to take those identities and put them into practice. If all else fails, guys, and you don't know what else to do, you're looking and you're like, I don't even know where to start, convert to sine and cosine. A lot of times that'll help. And the last thing I ask you, please just try something. Even if you're just staring at it like, I don't know, just try something. Try something. You might hit upon something that goes, oh, that makes sense. We can go to the next one. All right, let's go to an example. First thing you should do is have your identities right next to you. So take them, post them, stick them right next to you so you guys can see. So do you see this problem here? It says verify the identity. They're telling you guys, I'm telling you from the beginning, the left-hand side equals the right-hand side. I'm not going to give you any that aren't true. I'm not going to throw you any curveballs that's like, haha, this one doesn't work. Not going to be the case. So the first thing we're going to do is we're going to make a little T-chart. And then I want you to tell me which side looks more complicated. The left-hand side, correct. So we're going to leave the right-hand side alone. I know that I am trying to get the left-hand side to say sine squared. I know the end game. So I look here, I say, okay, what do I need to do here? Well, first thing we ask ourselves, do we have a trig function that is squared that has a plus or minus 1 attached to it? Yes. Can I replace secant squared theta minus 1 with something? What? Tangent squared. So do that. I'm going to rewrite this as tangent squared theta over secant squared theta. Now use this as a guide. We're trying to get the left-hand side to say sine squared. So we're on the right track. We got rid of now plus and minuses. That's good. So now we're back to just two trig functions. No more Pythagorean identities. So when we get to this point, we could say, okay, what are the two most basic trig functions? Sine and cosine. So let's change everything to that, see what happens. So my numerator, tangent, becomes what? So sine squared over cosine squared. Perfect. Divided by, what does my denominator become? 1 over cosine squared. Perfect. All right, well, did that help us a ton? Kind of. Algebraically, what am I looking at? Keep, change, flip. A fraction divided by a fraction. So we keep, change, flip. So I have sine squared over cosine squared times, what happens? Flip it. So cosine over 1. Agreed? All right, now what happens, guys?
Cancel.
The cosines cancel, and you're left with what? Sine squared theta. Is that what we were trying to get to? So sine squared theta equals sine squared theta. Now, let me explain something to you. The answer to this question is not at the bottom where I put sine squared theta equals sine squared theta and a check mark. I already know that, guys, right? Didn't we know that from the beginning? They told me the left-hand side equals the right-hand side. So this, ladies and gents, is the answer to your problem, right? The proof showing me mathematically that the left-hand side equals the right-hand side is the answer to this question. Now remember, I've been teaching for a few years, right? This is year 20. It's not the first time I've done this. So some of you are going to get confused and you're going to get overwhelmed and you're going to just start writing random trig stuff down. And then at the bottom right, sine squared equals sine squared and a check mark and be like, she'll never know. She'll know, guys. It takes me a little longer to check these because I have to actually go through all of yours and make sure they make sense. Now, some of you are going to see things differently than I do, which is fine. This is not just one way to do it. You can apply the identity. As long as mathematically it makes sense, you're good to go. But I will go through and make sure that it makes sense. The answer is not sine squared equals sine squared. The answer is what I have circled in green that shows why the left-hand side is the same as the right. Does that make sense? Let's do two more, then we're done. Oh, this one looks super, huh? We have fractions, guys. Isn't fractions so much fun? Miss Carver just said, what are you guys doing today? I said, verifying. She goes, oh my gosh, I love that stuff. She told me that you came to see her. And she was like, oh my God, I love it. It's fun. Once you get the hang of it, it's not bad. All right, which side looks more complicated? The right, for sure. All right, now think algebraically, guys, what are we looking at? We're looking at two fractions, and we're doing what to them? We're adding them. Okay, so think. All right, let's just think for a second. I have 1/2 plus 1/3. What's my common denominator? 6. Okay, I have 1 over x plus 3 over y. What's my common denominator? xy. How'd you get that? You multiplied them. How'd you get 2 times 3 is 6? What's my common denominator between 1 minus sine alpha and 1 plus sine alpha? Well, hold on. We're advanced. You're advanced there, Chloe. How do I get a common denominator? I'm going to multiply them. So I'm just going to take 1 minus sine of alpha, and I'm going to stick it with 1 plus the sine of alpha. Right? How do you get a common denominator between fractions? Multiply the denominators. Just stick them together. So now we're going to go back to algebra. We're going to go back to 4th grade. We have a common denominator. Now we have to say, okay, my first fraction. My numerator has the 1 minus sine alpha. Go ahead.
Well, you can't put 1 minus sine alpha
Yeah, you're one step ahead of us. You can. If you see it, yeah, you can. You guys will see what Chloe and Brian are talking about in a second. All right, my first fraction has the 1 minus sine alpha. What does it need so it has a common denominator? The 1 plus, right? Okay. The second fraction has the 1 plus. What does it need? The 1 minus. All right, perfect. So let's multiply. 1 times 1 is 1. 1 times sine alpha is plus sine alpha. Plus 1 times 1 is 1. And 1 times negative is minus sine alpha. Everybody with me? Okay, I know there's words in here, but the math is still mathing. We're going to combine like terms. So in the numerator, guys, everybody with me, what is 1 plus 1?
No.
Perfect. What's a positive sine alpha and a negative sine alpha? It cancels out. Wonderful. Now, let's take a step for a second and look. Where are we trying to get to? 2 secant squared. Have we already discovered the 2 that we were looking for? Yeah, okay, good. Now, if I had x plus 3 times x minus 2, and I said to you guys, well, what do I do with that? What would you tell me to do? FOIL. All right, I have a binomial times a binomial. We're going to FOIL. What's 1 times 1? 1. What's 1 times positive sine? Plus sine alpha, good. What's negative sine times 1? Minus sine alpha. What's negative sine and a positive sine? Minus sine squared alpha. All right, we're still doing algebra. So in my numerator, I have 2. What happens with my signs in the middle? They cancel, so I have 1 minus sine squared, which is what Brian and Chloe said a minute ago. Now, soon you guys should start seeing 1 minus sine squared. Wait a second, I think that equals something. What's the Pythagorean identity that could help us here? Sine squared plus cosine squared equals what? 1. How can I rewrite this so it says 1 minus sine squared?
Subtract sine.
If I subtract sine from both sides, what does it equal? Perfect. All right, now where am I trying to go to? Secant. Is there a relationship, guys, between secant and cosine? How can I rewrite 2 over cosine squared? Yep.
Where did we get this sine squared plus cosine squared?
From your Pythagorean identities.
I know, but why is it there? I think I got
Okay, do you see how in blue how we have 1 minus sine squared?
it. Yeah.
So I thought to myself, okay, I have an identity. I have something squared that has a plus or minus 1 attached to it. So I looked at my Pythagorean identities and I said, which identity has a sine squared and a 1 in it? And it's that top one. So I wanted to see if I could simplify, if I could make it smaller with anything.
Oh, okay.
Does that make sense? So if you look at your reciprocal identities, look in the middle of your identity sheet, you see it says reciprocal? Do you see how secant is 1 over cosine?
Yeah.
So say you had like 5 over cosine. It would be the same as 5 secant. You can rewrite because they're reciprocal identities of each other.
Wait, in the beginning, you know, it's like 1 minus sine.
Huh?
I thought it would be like cosine.
No, because that's a good question. Guys, look, that's a very good question. Guys, look, do you see how you have 1 minus sine at the beginning? We had 1 minus sine. 1 minus sine is not the same as cosine. The identity is 1 minus sine squared. It has to, if you're going to have something squared and attached to a plus or minus 1, then you can change it to a Pythagorean identity. But just because it's 1 minus sine, that doesn't make it cosine. It has to be squared. All right, let's do the last one. Let's do number 3, and then we'll be done. You guys are doing great. All right, again, you should have your identities right next to you. Go ahead and make your T-chart. This one's a little easier. There's a little trick in here. That's why I want to do it. But this is a little easier because we don't have any fractions. We don't have to get common denominators, all that stuff. Which side looks more simplified? The right. So we're going to work on the left one, right? So when I look at the left-hand side, I have tangent squared plus 1. I have cosine squared minus 1. Notice you both, guys, in both situations, you have a trig function squared with a plus or minus 1. So where should your eyes look on your chart? Your identities. Good. So let's deal with the first one. Tangent squared x plus 1. Look at your Pythagorean identities. What can I replace that with? Secant squared. Wonderful. So this becomes secant squared. I'm just going to use theta. Now, this next one is a little tricky. Cosine squared, and it's attached with a 1. Which Pythagorean identity deals with cosine squared and has a 1? The first one, sine squared plus cosine squared equals 1, right? So let's think about this for a second. I needed to say cosine x minus 1. Well, my first thought would be to move the cosine, right? So I have sine squared theta equals 1 minus cosine squared theta. Are these two things right here the same? They're not the same, but they're close, yeah? Right? All right, so there's a couple things you can do here. Some of you are already seeing it. Oh, it's negative sine squared. Let's think about what we can do. Think algebraically, all right? If I think algebraically, if I want to change the signs of everything in an equation, what do I multiply or divide by? Negative 1, right? Look, if I multiply or divide, if I divide this whole thing by negative 1, do you guys agree this becomes negative sine squared equals negative 1 plus cosine squared? So is this now the same? Yeah. Okay, that's fine. If you saw that, you did that, perfectly fine. Somebody in J period said, well, I took this, sine squared plus cosine squared equals 1. And she said, I moved the 1 over. So she got sine squared plus cosine squared minus 1 equals 0. You guys with me? And then what did she do? Then she subtracted the sine squared. And she had cosine squared minus 1 equals negative sine squared. Is that right? That's fine, because algebraically you're allowed to do that. Perfect, good. See, some of you are going to see stuff differently. You know how I did it this morning when I was looking at the notes? I said, okay, I have cosine squared x minus 1. I'm like, what can I do here? Well, I replaced cosine squared with sine squared x. No, I didn't. Just kidding. With 1 minus sine squared. We've already seen that, haven't we? In these examples? Cosine squared is the same as 1 minus. And then when you simplify, my 1's cancel out, and I'm left with what? Negative sine squared. 3 different ways to manipulate that is perfectly fine, as long as you use your algebra skills, guys. What you do to one side of the equation, you do where? To the other. If you're moving something that's positive on one side to the other side, you subtract it. If you're moving something from one side to the other that's negative, you add it, whatever. You do not lose your algebra skills. So cosine squared x minus 1 is the same as negative sine squared x. 3 different people just had 3 different thoughts on it, which is totally fine. So now I look at this and I'm like, oh, thank goodness. We don't have any fractions. We don't have any plus or minus 1s or anything like that. Now I just go to my 2 most basic trig functions, which are sine and cosine. So secant, I'm going to replace with 1 over cosine squared. So this should be theta, sorry. I'm going to keep sine, because it's already basic. Now remember, where are we trying to get to? Tangent, right? Is there a relationship, guys, on between the left-hand side and the right-hand side? Yeah, you should always be able to kind of look and see I'm on the right track. If I multiply these together, I have negative sine squared over cosine squared. Look at your identity sheet. We should already probably know this, but sine over cosine is the same as tangent. So this is negative tangent squared theta. And what did I want it to equal? Negative tangent squared theta. We're good. Or x, whatever letter. I just like theta. Now, when you guys do these problems, it should not take you like 15 steps. I'm not going to give you ones that are that involved. If it does, and you get to the right answer, that's fine. Some of you might take the long way to get there. But I cannot impress upon you enough the importance of practicing this. If you guys don't practice this, you're not going to get better at it. And there's some of you that I know you're not going to admit it out loud to anybody. You're going to be like, oh my God, I get this. This is kind of fun. You start to feel like a sense of accomplishment when you start to make it make sense, I promise.